The cool thing about this rig that we're about to build is that it's not actually specific to the torso rig. You can apply this rig to any rig that's based around a single bone chain, but with one restriction. All of the controls of that rig have to be outside of the bone chain. That's why we made the middle control of the torso rig a separate bone. In any case, it's helpful to think of this as a separate rig from the rest of the torso. It can be applied to any bone chain. We just happen to be applying it to the torso. Understanding how this rig construction works is a little tricky. In fact, I often forget how to rig it, and then I have to go and look at previous rigs to figure it out again. I don't even remember exactly how I figured this out in the first place, except that I'm pretty sure it involved a lot of banging my head against a wall. So I apologize in advance if any of the explanations for this aren't entirely clear, but I'll do my best. The important thing to realize, though, is that when I developed this rig, I did have a clear idea of how I wanted it to behave, and once I knew how I wanted it to behave, I tried all kinds of different things to try to create that behavior. What I came up with was something I call a reverse chain rig, and that's because we'll be creating a bone chain that is the exact reverse of the torso chain. Let's consider the 2D case. And for now, let's just consider two bones, and let's also just draw them as lines. And now let's make a parallelogram out of it, using a different color. Wait, why are we doing that? Well, take a look at what happens when we slide our original bone chain down on it. There are always at least 2 points of contact, here and here. As long as one of these points touches, the other will as well. So, for example, we could think of this as sliding this point on the white bone chain along the length of the blue bone chain. And doing that guarantees that this point of contact also stays intact. Now imagine that we were to rotate the blue bone chain, taking the white bone chain with it. The white bone chain is now effectively rotating around this point as a pivot point. We can even bend the sides of the parallelogram, and that point stays put, as long as this point remains at the same point on the blue parallelogram. This is pretty abstract, but this is the principle behind the rig we're about to build. The important thing to realize is that this works for bone chains of arbitrary lengths as well. We can think of the blue chain as basically being the reverse of the white chain. If we draw the bones on top, it becomes more obvious. As long as we maintain that reverse relationship, the bone chain can be as long as we like, and all of this will still work. So going back into Blender, let's see how we can exploit this. What we want to do is create a second bone chain that does the exact reverse of this chain at all times, and that this chain will slide along. Now, the first thing to consider is dependency issues. If we create a second chain, and constrain it to the opposite of the original, we're going to run into a cyclic dependency, because the original is also supposed to be constrained to the second chain to slide along it. So instead, what we're going to do is create a third chain, sort of like a control chain, that will determine the rotation of both of the others, so that they have no dependency between each other. So with that out of the way, now we need to figure out how to create the reverse chain. One clever way to do that is by observing that, really, a reverse chain is just a reordering of the original bones. We can reparent all of these bones in reverse order, like this. And if we switch to stick display, we can see that they do exactly the opposite of each other. As long as the orientation of the respective bones in this chain are the same, the second chain will always be the precise reverse of the first. Let's constrain the rotation of these bones to the control chain. Now when we rotate the control chain, the original and reverse chains stay in a parallelogram type configuration. No matter what we do, their endpoints always meet. So this seems to work pretty well, but there is a problem. how do we slide the original chain down the reverse chain? With this configuration, we would need to make the very tip of the original chain slide down the other chain. But we can't do that directly. We can only directly control the location of the base of the bone chain. So how can we remedy this? Well, what we can do is put our reverse chain back down here. Now sliding the base bone of the original chain down the reverse chain will work just fine. The same principle is still in effect. But now we have another problem, which is that the reverse chain doesn't stay put like we want when we rotate the control chain. Sigh. So this is where things really get a bit weird. To fix this, we're going to delete the constraints on the reverse chain, flip all of its bones with Alt-F, and make them the children of their respective bones in the control chain. Since they are the children of their respective bones in the control chain, they will always reproduce their rotation, just with the flipped position. Now we can constrain them to each other via copy locations to keep them in a chain formation. However, this doesn't work how we want on its own. We want this bone to stick to the tip of the first bone, not its base. We could add a bone at the first bone's tip and constrain to that, but Blender has a simpler way. If you go to the constraint properties, you'll see a slider called head/tail. This slider lets us determine where along the length of the first bone we're constraining the second bone to. So if we slide it all the way to 1.0, now the bone is copying the location of the tip of the other bone, rather than its base. Now just do that for the rest of the bones in the chain. We also need to add a bone for the base bone to stick to. Now when we rotate the control chain, the reverse chain behaves exactly how we want. And it works in all 3 dimensions. So now we just need to make the original chain slide along the reverse chain. It turns out this is pretty easy. If we constrain the location of the original chain to the second bone in the reverse chain, then when we slide its influence off and on, the chain slides along the length of the first bone. This is because it's blending between its original location and the location of the second bone. Even if we leave it with partial influence, this setup still works. Notice that the pivot point of the original chain is now effectively moved. The only problem here is that if we move the location of the reverse chain, well, the original chain doesn't properly stick. That makes sense though, because we never constrained the original chain to move with the reverse chain in the first place. So let's add a copy location constraint for that, and move the constraint above the copy location to the second bone. Now we can just constrain it to each of the remaining bones in turn. And for the last bone, let's also add a last constraint to constrain the chain to the tip. Now by sliding these constraints off in sequence, or on in sequence, we can slide the original chain along the length of the reverse chain. And wherever it is, rotating the control chain will result in the original chain rotating around this pivot point. We can see this even better if we move the reverse chain to a hidden layer. However, we obviously don't want the animator dealing with 4 separate sliders to shift the pivot point of the chain. So on this bone here, which now essentially serves to translate the chain around, let's create a custom property that will do this all in one slider. Let's name it Pivot Slide, and make sure its min and max are 0 and 1. Now let's add a driver to the first constraint's influence, and set up the driver to use the custom property. So now we can control this one step of the sliding with our property. But really, we want the property to handle all 4 of the constraints in sequence. So that means we want the property to fully turn on this constraint by the time it hits 1/4, or 0.25, and then turn on the next one by 0.5, and then the next by 0.75, and so on. To do that, we can simply multiply our variable by the number of bones, in this case 4, and give it an offset. For the first slider, we don't need an offset, so just multiply it by 4. Now the first constraint triggers by the time the property gets to 0.25, because 0.25 times 4 is 1. So now let's copy and paste this driver to the other constraint influences and tweak their expressions. The only tweaking we need to do is to put in the appropriate offsets. This turns out to be really simple. We just subtract increments of 1.0 for each subsequent constraint. Ta-da! You can work out for yourself why those driver expressions work. The important insight is that values less than 0 or more than 1 become 0 and 1 respectively in the constraints influence sliders, since those are the minimum and maximum values that constraint influences can have. If you don't want to go through all of the hassle of that math, you can instead create F-curves for each driver to do the same thing. Either way works just as well. We're pretty much done here now. There are just a couple of things to change. The first is that since by default the torso will pivot from the hips, it would be good to position the original and reverse chains in edit mode so that that's the case. We can figure out what those positions are by looking at what it looks like in pose mode. Okay, so this is how the original and reverse chains should be positioned relative to each other in edit mode. Let's make it so. Now it doesn't shift when going in and out of edit mode. Yay! The second and final thing is that we can replace the copy rotation constraints on the original chain with copy transform constraints. In fact, I recommend that you do this. This way, any squash and stretch, or in fact whatever craziness you set up on the control chain, will transfer over properly. Now you can do pretty much whatever you want to this control chain, and the pivot slide will still work. Crazy, eh? And all of this can be done for bone chains of any length. Then, when you want to figure out your control scheme, all you have to do is layer it over the control chain. Anyway, that's it for the torso. We still need to put this thing and the thing from the last video together, but that's pretty simple. We just layer it over the control chain. We'll do this in the final assembly of the character rig.